Falcon 9 rocket for NASA's and SpaceX's 25th commercial resupply services mission. The Dragon spacecraft you see there will fly more than 5,800 pounds of science, supplies, and food for the astronauts aboard the International Space Station.
Good evening. I'm NASA's Sandra Jones here inside the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. Mission Control Houston is the nerve center for space station operations, and our flight control team is on console and ready to support today's cargo launch. Leading the team in mission control during today's launch is NASA Flight Director Scott Stover. You see him there on your screen right there. And when Dragon arrives to the International Space Station on Saturday, it will dock to the station's forward port of the Harmony module. NASA astronauts Bob Hines and Jessica Watkins will be on tap to monitor that approach. Dragon is slated to spend about 1 month attached to the International Space Station before it returns to Earth with research and return cargo and splashes down off the coast of Florida. For now, everything continuing to look good on the station side for today's launch, so back over to you, Megan.
Thinking about Sandra, and before that, Daryl. We are now about 17 minutes and counting from liftoff of CRS-25. Let's check out some of the science flying on this mission. A lot of impactful research going up with today's launch, and let's take a closer look at some of those that you saw in that video, starting first with EMIT, which stands for Earth Surface Mineral Dust Source Investigation. Joining me now is EMIT's principal investigator, Rob Green, and we also have NASA's Senior Climate Advisor, Dr. Kate Calvin. Great to have you here.
Wonderful to be here.
Perfect. So let's take a look at some video of EMIT, Rob. So
okay.
EMIT is going to be attached to the outside of the space station,
Yes.
and it's going to study mineral dust. But what is mineral dust?
So mineral dust are the tiny particles of rocks in the dry land regions of our planet that under conditions of high winds are launched into the atmosphere. In the atmosphere, because they can be different compositions, they can heat or cool our planet, play a role in cloud formation, and many other impacts. Right now, we know about mineral dust by about 5,000 different measurements that have been analyzed around the Earth. When EMIT is done, we will have 1 billion direct observations of the minerals in these dry land regions to advance the science of how mineral dust can heat or cool our planet.
And I think it's important to understand for people that, you know, we're not just focused on these arid regions. When you have dust storms, you can see a dust storm in Africa end up affecting us in Texas per se. So why is it important to study these dust storms, and in particular to understand how they might heat or cool the Earth?
Well, as you point out, it's a global phenomenon on every continent except perhaps Antarctica, and that dust can travel thousands of miles from Africa to Florida to Texas, and it has impacts throughout the Earth system there. And then heating or cooling, when you have a global phenomena, you've got to take it into account. Are those dust particles absorbing energy, heating our planet, or are they scattering light back into space and cooling our planet? So we need this information so the Earth system models become more accurate, so we understand what's happening now and in the future. And those are the two primary objectives of EMIT.
Yeah, so Kate, it sounds like EMIT is going to be a real tool for us when we're studying climate change and just the Earth's climate. And it's no surprise that EMIT is one of a fleet of Earth observing spacecraft.
Yeah, one of NASA's most important missions is our home planet. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that observe the Earth. So we can see things like carbon dioxide, vegetation, changes in the mass of ice sheets, and much more. And once EMIT is put onto the International Space Station, it'll join that fleet.
Wow. And I do know that it's not just what we have orbiting the Earth, there's also a lot of research being done on the ground. So when you consider this whole portfolio of climate research that we're doing, how will this help us address climate change?
Well, the more we know about the planet, the more we can use that to provide to local decision makers, stakeholders, and the public about what's happening on Earth.
Awesome. Guys, thank you so much. I appreciate your time.
Thank you.
And EMIT isn't the only experiment inside Dragon that will study Earth's climate. Students from MIT built what you're about to see on the screen here. This is called Beaver Cube, and it's named after the school's mascot, Tim the Beaver. It's a small satellite about the size of a shoebox, and once deployed, it will measure cloud properties, ocean surface temperatures, and ocean color to analyze Earth's climate and weather systems. T-minus about 11 minutes and counting from liftoff of NASA's and SpaceX's 25th commercial resupply services mission to the International Space Station. Let's bring back Shiva now to tell us more about Dragon.
Thanks, Megan. Now, Dragon is capable of transporting people as well as environmentally sensitive cargo to and from Earth orbit, like we are on today's mission. Starting from the top of the nose cone to the bottom of the trunk, it stands about 27 feet tall and is made up of two main sections. The pressurized capsule and the trunk, which is used for unpressurized cargo and supports the spacecraft on ascent and during on-orbit operations. Now, after separating from Falcon 9, Dragon will autonomously make its way to the International Space Station using its navigation sensors and its engines. The capsule has 16 Draco engines, which are used to get the spacecraft from one place to the next. Now, we've got 12 of those service section Dracos near the bottom of the capsule and 4 near the top of the forward bulkhead underneath the nose cone. Those forward bulkhead Dracos are primarily used for high thrust maneuvers like the orbit changes that we'll need to get to station and eventually in about a month to get back home to Earth. Each of those thrusters are capable of generating about 90 pounds of force in the vacuum of space. Now, the service section Dracos are used primarily for pointing and for operations in proximity to the space station. You can actually see them firing here in these clips taken from the International Space Station on various different Dragon missions as they were approaching the orbiting laboratory. And just like those Merlin engines on Falcon, we also reuse the Dragon thrusters, the Draco thrusters, once that spacecraft returns to Earth. Dragon and Falcon continue to remain in good health, and we're ready to support the on-time liftoff around 8:44 p.m. With that, back to you, Megan.
Perfect news, Shiva. That's what we like to hear. And two people very excited about today's launch are right here next to me. We have Claire Green and Benjamin Whitfield, both of Arkansas State University. They actually have an experiment on board and are about to tell us about it. Great to have you here.
Nice to be here.
All right, you're so excited. I love it. So let's take a look at the screen. We have some pictures of when the team was here earlier a couple of weeks ago, and you guys were prepping your experiment. What are you guys studying?
So we are studying waxworm larvae and their unique ability to break down thin plastics, thin plastic bags, into a non-pollutive byproduct. And we're very curious to see if they could still do this process in microgravity or aboard the space station.
Yeah, so we know that this happens on Earth. Why do you want to see if this happens in microgravity?
Well, the application of breaking down plastics is beneficial anywhere. It's a problem that we're learning how to deal with. So if we can learn how to deal with it on Earth and in the space station, then we can extrapolate that to other environments.
Why are you guys interested to see how this will react in space? Is it because we as an organization, NASA, we are thinking about going farther than we've ever been before?
That's exactly what it is we are proposing this as a long-term space travel waste management system because plastic, it's lightweight, it's cost-effective, it's not going anywhere, and we don't want a pollution problem like we've had on Earth.
Yeah, perfect. So I know that this is the first launch for both of you. Why don't we take a look around really quick? So there it is on the launch pad, Falcon 9 and Dragon. Inside Dragon is your experiment. How are you guys feeling?
It is surreal. It feels like a dream, and it's about to be a dream come true, not just for myself and Claire, but for our whole team, for students at Stanford who also have an experiment going up, and for all the students who assisted us in our citizen science.
Perfect. Guys, I cannot wait to see what you discover. Thank you so much for your time, and I hope you enjoyed the launch.
Thank you so much.
And we have another student experiment on board Dragon today. These guys are in college, but we have a high schooler here. You see Celine Coquelar. She won the annual Genes in Space research competition by designing a new method of detecting water contaminants. If successful, her work could be used to test water quality both in space and also remote parts of the Earth. Genes in Space is made possible through Boeing, a startup called Mini PCR that makes equipment for biology research, and the ISS National Lab. All right, we're just under 6 minutes till, oh no, 6:56. I am having a hard time, guys, but we're close to terminal count. So let's bring back Shiva live from SpaceX headquarters in Hawthorne, California, and Daryl here on Florida Space Coast to walk us through the final moments of the countdown. Guys, take it away.
Thanks, Megan. Now, the SpaceX team is not working any significant issues with both Falcon or Dragon at the moment. And the weather, I hope, is continuing to trend well. Like Daryl had mentioned earlier, we're keeping an eye on some clouds and potential precipitation. And we're going to keep our ear out to the loops to make sure we remain go for launch. The range does remain go for launch at this time. Now, at this point, the Rocket Propellant 1 fuel is completely loaded on the second stage and nearly fully loaded on the first stage. Liquid oxygen loading is underway on both the stages. That'll complete at about T-2 minutes to launch. At this point, we're also loading helium gas into both the stages. Falcon 9 uses that helium as a pressurant to backfill the propellant tanks as we consume that liquid oxygen and RP1 by the Merlin engines during ascent. Helium load began before the broadcast went live, and it'll continue to top up until about a minute and a half before the launch.
To make sure engine startup goes well, SpaceX performs an engine chill. This happened, will happen, has happened at T-7 minutes. Flowed a small amount of the super chilled LOX into the Merlin engine's turbo pumps. And this is done to avoid a thermal shock to the system when that flow of super chilled liquid oxygen hits the prop system. Now, Dragon began its startup sequence at T-35 minutes when it coordinated timing with the Falcon 9. Dragon now currently undergoing vehicle health checks with the next big step just before liftoff when the cargo spacecraft transitions to internal battery power.
Dragon is in terminal count.
And we just heard that call out for Dragon being in terminal count. And the strong back retract, that's perfect timing. That large truss structure next to the vehicle is called the transporter erector or the strong back. And as was called out on the loops, it pulls away from the vehicle in preparation for liftoff. We'll see those clamp arms around the body of the second stage start to retract. And then shortly after that, the whole structure will pull away from Falcon 9. Now, in these last few minutes, Falcon 9 is performing a set of final health checks on its primary communications, avionics, and propulsion systems in preparation for liftoff just about 4 minutes away from now. We're also going to continue to hear callouts throughout that the engines are sufficiently chilled in as we get closer to liftoff. And on our screen right there, you can see those clamp arms beginning to open around the second stage in between some of that cooling of the Florida air around the second stage. And shortly after, we'll see the white truss structure on the right-hand side of the vehicle begin to pull away from Falcon 9. There you can start to see motion of the transporter erector away. It'll recline a bit before we step further into the liftoff.
And coming up in just about a minute, Shiva, checkouts of the second stage thrust vector control actuators. They are underway. This is often referred to as the engine wiggle test. This is when SpaceX moves the thrust nozzles slightly to make sure that the guidance hardware is go for flight. Again, that was a great view of the transporter erector tilting back. SpaceX does the exact same checkouts of the first stage engines, and that happens just seconds before ignition. At the time of launch, 8:44 and 22 seconds p.m. Eastern Time, the International Space Station will be over the Pacific Ocean, 257 statute miles in altitude.
Now, we actually heard just about 30 seconds ago that liquid oxygen loading is complete on the first stage. And coming up here, just under 20 seconds, we'll hear a similar call out on the second stage. That will wrap up propellant loading on Falcon 9 in preparation for launch. At this point, Dragon is performing its final health checks to make sure we're ready to go for rendezvous with the space station about 38 hours from now. And I love this shot of the pad. You can see the clouds forming around Falcon 9
Stage 2
from
LOX
that
load complete.
cooling. There's a call out there for LOX load complete. You can hear or see the water vapor condensing and forming
Dragon is in auto
clouds
idle.
around Falcon 9.
Yeah, you sure can. And just a few minutes left in twilight. A little bit of illumination makes it nice. At T-minus 1 minute, Dragon will transition to internal power. Falcon 9 computers will enter startup mode and begin final pre-launch checks, guiding the rocket through the last seconds before liftoff.
Falcon 9 is in startup.
There you have the call.
Dragon is in countdown.
Both stages are now pressurizing for launch.
LD is go for Falcon 9, CRS-25 launch.
So range is go, weather is go.
T-minus 30 seconds.
It's a beautiful time of day to watch this launch if you're out on the beach.
T-minus 15.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Power and telemetry nominal.
We are 50 seconds into flight. Successful liftoff from the Kennedy Space Center, Launch Complex 39A. Falcon 9 is heading towards its next major milestone. That's for the point of highest stresses that the vehicle will experience during ascent. There's the call out for maximum dynamic pressure. So from here, the stresses on the vehicle will get lower and lower as we raise our altitude. Coming up, we've got 5 events back to back. The first of those will be main engine cutoff, or MECO. That's where all 9 Merlin 1D engines on the first stage will shut down.
I'm back, chill.
Following that will be stage separation, where the first and second stages will separate. The first stage will flip around to make sure it's headed back towards the landing site and our drone ship named a shortfall of gravitas. And then the second stage will ignite its Merlin vacuum engine to boost Dragon into low Earth orbit during second engine start number 1. We just heard the call out there for engine chill-in on the second stage engine starting. The last event is the boost back burn on the first stage. That's to reduce the velocity of that vehicle as we prepare for atmospheric entry. Now, all of those events happen over about 45 seconds. And again, they are main engine cutoff, followed by stage separation, first stage flip, second stage engine start, and then boost back burn start. All those happening in just about 5 seconds.
MECO. Stage separation confirmed.
Fantastic sight.
I'm back, startup.
So the first 3 of those events are complete. And now the boost back burn is underway. The shot on our screen right now is of the Merlin vacuum engine on the second stage. And as this view toggles, you may catch the first stage. It is firing its Merlin 1D engines that burn on the first stage, lasting about 30 seconds. And you can see the plume on the first stage on the left-hand side of your screen as we're doing the boost back burn.
Stage 1 boost back shutdown.
Successful shutdown of the first stage Merlin engines for the boost back burn. Second stage engine continuing to burn. That'll continue to burn until about the T+8 minute and 40-second mark into the mission. Now, if you're just joining us, welcome to our 25th commercial resupply mission to the International Space Station for our customer NASA. You're watching our 30th mission of 2022 and the 3rd Dragon flight to the International Space Station this year. We lifted off just about 4 minutes ago from the Kennedy Space Center in Florida. On your screen are views of our first stage on the left-hand side of your screen with its grid fins deployed periodically, controlling its attitude to make its way back home. On the right-hand side of your screen is a shot of the Merlin vacuum engine on the second stage, performing its burn. It'll continue to burn for about another 4 minutes to take Dragon up to low Earth orbit. Now, speaking of the entry sequence on the first stage, to make its way back to that drone ship, it's going to have to execute 2 more burns. The first of those is the entry burn, where we'll ignite 3 of the Merlin engines, and that helps slow down the stage as we enter the upper part of the Earth's atmosphere. Following that, there will be a second burn, the landing burn, and there will only ignite a single Merlin 1D engine that'll bring the vehicle speed down to 0 for a soft touchdown on the drone ship. We've got some great sunlight on the vehicle, and you're periodically seeing some plumes of white. That's actually from our nitrogen gas thrusters that are helping to keep the first stage oriented, engines down, as we are in the vacuum of space at the moment. But once we get through that entry burn, the grid fins, which are deployed, you can see 2 of them on your screen, will then take over control as we start to get atmospheric authority. And then the first stage will only use those grid fins to steer back towards our drone ship. So entry burn expected to start about 10 seconds for now.
Stage 1 FTS is saved.
Just taking a quick look in, stage 2 engine performance, about nominal. Continuing to burn. We've got about 3 more minutes for that burn.
Stage 1 entry burn startup.
So you can see the velocity on the first stage, bottom left-hand side of your screen, rapidly slowing down as we fire
entry burn shutdown.
the entry burn. That burn only lasting about 15 seconds. And now we're doing a quick attitude correction to make sure we're pointing the heat shield down. And that entry burn and the plume coming back on the stage ends up depositing a small layer of carbon on the vehicle, which is what gives our first stages that awesome sooty look once we've reflown them. Now, Falcon 9 also has 4 landing legs. They're made of carbon fiber and aluminum honeycomb. They're placed around the base of the rocket, and they'll deploy just prior to landing during the landing burn. If we're successful in recovering this Falcon 9, it'll mark its 5th successful landing and our 130th landing overall of a Falcon 9, including Falcon Heavy missions. So landing burn coming up shortly.
Stage 1 landing burn.
Keep an eye out on the speed on the left-hand side of your screen. That's the velocity of the first stage. We're going to see that come all the way down to 0. On the right-hand side of your screen is our drone ship. And also keep an eye out on the left-hand side of your screen for landing leg deploy.
Stage 1 landing leg deploy.
People real excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket.